Let's get started with this series about object-oriented programming. What am I going to cover in this introduction video? First of all, meet Drawing App, the application that will serve as common thread of this playlist and which we will implement from scratch. Now, before implementing a program, in our case in Java, it's always a good idea to know what you have to implement, to have a goal. Well, that goal can be achieved by performing an analysis first, the result of which will serve as a starting point of the implementation. The analysis will result in specifications, and the specifications are then translated, so to speak, to UML diagrams. In our case, a UML class diagram. And from the UML class diagram, we move on to the implementation in Java. I'll say something about avoiding duplicate code by implementing part of your code in a library and use it in another part called the application. And finally, get the IDE or Integrated Development Environment ready. And I'll use IntelliJ to prepare the project ready for the implementation in Java. Let's start at the beginning. Suppose a customer asks you to develop an app that allows users to draw shapes, rectangles and circles to be more precise. Now, to make things a bit more visual, I have a running instance of such an app. It is a small desktop application that I wrote in JavaFX, and it enables me to draw those basic shapes. So here I have a menu, a toolbar, indicating the shape that I can draw, rectangle and circle, and down below I have the status bar that will display some additional information. So in order to draw a rectangle, very easy, I select a starting point where I want the rectangle to be located, then I click on the mouse and that point will form the starting point of the rectangle, so the top left point. When I hover over it, we see the properties down below in the status bar. The starting point has a coordinate x and y with values of x 100 starting from the left and y 53 starting from the top of this plane. Now the toolbar doesn't form part of the plane. The height, the h, is 117 pixels and the width is 200 pixels, the w. I can move the rectangle around and then of course we see the x and y coordinates change. The size remains the same. If I want to change the size, I double click on the rectangle, a dialog box pops up and I can change all four properties, x, y, height and width. Let's make this a little higher, so 200 and smaller, 50. Press OK and my shape has changed. Now I can draw circles as well and handle them in the same way. So that's basically it. And so suppose that the application doesn't exist and your customer explains his wishes of Drawing App to you with pen and paper. Where to start from then on? What would be a step-by-step plan? The first step would be to perform an analysis of the requirements of the customer. What does he want? Then use the output of the analysis as input for the implementation, in our case in Java. Then test the implementation, and we will do that in a console application, and ultimately develop the graphical user interface program and the graphics program, for example with JavaFX. Now this is a recursive process. It's not that you perform the analysis only one time, implement and test it only once in order to create the so-called output products. No, there is a continuous back and forth jumping going on between 1 and 2, 2 and 3, 1 and 3, and so forth. Regarding the fourth point, JavaFX, developing a GUI, well, as for this OOP series, this playlist is not about developing GUI programs. I want to stick to the core, namely explain the OO concepts, and for that we don't need fancy graphical applications. Because before we can actually draw rectangles and circles, we need to first perform an analysis so as to come with clear definitions of what a circle is, what a rectangle is. Only then can we jump to step 2, implement, and step 3, test it. So let's start with point 1, the analysis. From analysis to specifications. Now, because I don't want to make this video too long, I'll perform the actual analysis in the other Getting Started video analysis of Drawing app. But use the end results, the outcome of the analysis, as a starting point in this slide. When we perform the analysis of the customer requirements, we come up with the following definitions for rectangle and circles. Based on what you've seen during my Drawing app demo, how would you define a rectangle? How would you define a circle? Well, in the other video, I will explain how I get the results that I will display now. So for a rectangle, in order to be able to draw it, we need two things. First of all, we need to know where to start to draw. We need a starting point, which we can obtain if we know its X and Y coordinates on a plane, as demonstrated during the demo. Now, something I didn't mention during the demo is, well, the plane is limited. The value of X and Y must lie within a certain range, and that range is between 0 and 1000. For the size of the rectangle, we need a height and a width, and there as well the limit will be 10. We can't use 0 because then the rectangle wouldn't be visible, so the minimum is 10, and with a maximum of 500. X, Y, height and width are nouns, which when used for definitions as an entity, such as rectangle, are called properties. So these four are the properties of rectangle. Now, we would also like to ask the rectangle to do something for us, so to speak. One thing is to print its current state on the screen, and the second thing is to calculate its area and perimeter. Now, print, get area, get perimeter are verbs which, when used for defining a rectangle, will be implemented as methods or functions. They do something. And what data types are we going to use for defining all this? Since our four properties are numbers, we will use the integer data type in Java. The print is a method that doesn't return anything, it's just performing some action, so its return type will be void. And for the get area and get perimeter, we'll decide that it has to return a float. Similar story for the circle. It has a starting position as well, denoted by X and Y, and their values must lie within the same range, 0 and 1000. Instead of height and width, a circle has a radius. The value must lie between 10 and 500. As well, what do we want a circle to do for us is to print its state on the screen and to calculate the area and perimeter. For data types, very similar, all integers for the properties, and then void for print and float for get area and get perimeter. Once the analysis provides a clear definition, we can move on to the next step, make everything visual. In other words, translate the data from the specifications of the analysis to a UML diagram. In this series, I'm only going to use class diagrams. And as this video series is meant to learn object-oriented programming step by step, I'm not going to implement all the specification in the first version. I'll do that gradually. So in version 1, I'm only going to define and implement the properties. In version 2, I'll add the methods. In version 3, I'll encapsulate everything, and so forth. And as I move ahead, I'll add more and more behavior in the program by implementing object-oriented techniques, while at the same time solve problems that we will be confronted with. Note, version 1.3 is definitely not the final version of our tour. There'll be about 9 versions in the first module, classes and objects, and about 6 versions in the second module, inheritance. Once we have the UML class diagram, the next step is to implement the classes from the class diagram in an OO language. In our case Java, but it could be other languages like C++ or C#. And in Java it looks like public class rectangle, public class circle, with the implementation between the curly braces. Now we will see all this from scratch. Then use those classes in a separate class called the application class or app, which is then going to use the rectangle and circle classes as it pleases. This is the class that gets executed, the actual program. And we can package everything in a console application, and when executed, the outputs will look something like this. Now, suppose that you've reached your goal with the rectangle and circle classes. Your console application is running as requested, and you want to use the library classes in a more fancy GUI using JavaFX. You might be tempted then to copy the rectangle and circle classes in the new JavaFX project and carry on from there. But it turns out not to be such a good idea to copy classes for every new client, because if the library classes in our first console project would contain some imperfections or errors, you'll import those into the new project. And second, changing, for instance, the class rectangle in one project would mean that you'll have to implement that change in the other project as well. That is not only time consuming, but error prone as well. We need a different approach. We have to make a clear separation between classes meant to be used and reused. We put those in a software library, and classes using the libraries. For simplicity's sake, we'll stick to application classes, but it could be classes in other libraries as well. The best approach is to create a project for a library of shapes which contains the implementations of rectangle and circle, and use that in another project containing the actual Java program, the application class called drawing app. And so we can reuse the same library over and over again for different clients. So here the GUI client uses the same library. Suppose you want to implement a mobile app, you can use the same library. No need to make copies of rectangle and circle. So a software library is source code that is meant to be reused in applications and or other libraries and cannot be executed. An application refers to a program that is supposed to use one or more libraries and can be executed. It can run. It's the actual app. Now, this concept about application using a library is very common. A common example would be, suppose a My app uses a system.out.println hi, but somebody else would use system.out.println how are you. So it's using this system class in a different way, printing out a different message, but it is using the same system class that is defined in the JDK, the Java Development Kit, which is installed on your platform. But we're using the same libraries. Now, how are we going to set up our IDE? Integrated Development Environments. It can be Eclipse. I'll use IntelliJ. So project setup. Well, there are two options. Option A, and eventually this is what we'll use. We create two projects in IntelliJ. One for the lib. In our source folders do we provide the source code. There's only one link to the JDK. And the second project, the app, which contains a link to the JDK, of course, but as well a link to this drawing lib. So two projects. I'm not going to use a Git. Instead, I use a new package per new version. With demo 1, I'll implement the properties. So I create a package as well in the lib project as in the app project. For demo 2, I'll add the methods and create separate versions per package. I prefer this approach for this series because it's an overview that is easier to follow. And again, to keep it simple, I'm not going to use Git. Note the package prefix DM stands for demo. So in short, option A is we create two projects, one for the lib, one for the app, and for each different version as we go along I create a separate package. That is one approach, but again, to keep it simple, what I'm going to do initially, easier for our purposes, is option B. Just create one project, drawing. How do I make the distinction then between what are the application classes and the library classes? I'll do that using Java packages as well. So in module 1 classes and object, I create a separate package for the app classes and for the lib classes. Application classes enable us to test the library classes as we go along. And then for the versions, again, no Git used. We use a new package per new version, as I demonstrated in the previous slide. Demo 1, for instance, variables, once in the app, once in the lib, and then add the rectangle class, and here's my drawing app client. So everything just in one project. link to external libraries only to the GDK. So now we're ready to put all this into practice in the hands-on project setup. So what am I going to do in the next video? Create one project. I put it on my D drive in a folder Java Under the Hood OOP, but you can use any location you want. I call the project Drawing, and I'll create two packages. Module 1 classes objects app and module 1 classes objects lib. That's it for this getting started introduction video. We'll see you in the hands-on video for this project setup. Thank you for watching.